Hello guys, welcome to another YouTube video. So for today's video, we'll be having the whole summary for the chapter 1 to chapter 11 in the CCNA 1. And let's get started. So I have here my PowerPoints ready. And here we have the chapter 1, which is the exploring the network. I have already made a summary of that, but this one's like a very short summary for each of the chapters. So in chapter 1, we have here the how networking impacts in our daily lives. So network support the way we learn, network support the way we communicate, network support the way we work, and network support the way we play. So the network helps us to in learning many great things, and also it helps us to communicate with one another, and it is how we do our work, because we do the work, we do the job, and it supports the way we play in our roles in our lives. So we have components of a network. We have the devices, media, and services. For the end devices, we have the computers, network printers, VIP phones, telepresence endpoint, security cameras, mobile handheld devices, such as that of the phones, tablets, PDAs, and wireless debit, credit card reader, and barcode scanner. So that's the end devices are the ones that we use, which is our physical devices like our phones and laptops and many more. Network infrastructure devices. So we have here the network devices, network access devices, internet working devices, and security devices. Now these types of networks, we have the local area network or the LAN, the wide area network or the WAN, and other types of networks are metropolitan area network or MAN, wireless LAN or WLAN, storage area network or SAN. Supporting network architecture, we have fault tolerance, scalability, quality of service, and security. So this is the guidelines that we need to follow when making or supporting our network architecture. Providing network security, we should be aware of the threats that can be that can occur in a network and on our own information. We need to provide security. Here we have the network trends. Bring your own device, because as 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 people living in a modern society, we need to bring our own devices, because that's how the trends work, and that's what we need. Online collaboration, we we are also given uh, we are also privileged to make some collaboration with other people using the internet and the network. For the video communication, we use video communication for conferences, and also for online studying, and it supports us in our needs whenever we have some questions. Cloud computing, this is where it we transfer data in a cloud, which is a server, where our information are gathered there in a single place, which can be a more secured storage. So organizational flexibility, agility, and rapid deployment, reduce cost of infrastructure, focus of IT resources, creation of new business models, network security. So this image shows us the internet and also the firewall that can that is destroyed by some external threat and can compromise our host and all the other hosts from the inside. Security threats, we have the viruses, worms, and Trojan horses, spyware, adware, zero-day attacks, also called zero-hour attacks, hacker attacks, denial of service, DOS attacks, data interception and theft, identity theft. So we have here the security solutions, antivirus and anti-spyware, firewall filtering, dedicated firewall systems, access control lists, intrusion prevention systems, and virtual private networks. The main summary: networks and the internet have changed the way we communicate, learn, work, and even play. Networking come in all sizes. They can range from simple networks consisting of two computers to networks connecting millions of devices. The internet is the largest network in existence. In fact, the term internet means a network of networks. The internet provides the services that enable us to connect and communicate with our families, friends, work, and interests. The network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur. It is made up of network components including end devices, intermediate devices, and network media. Networks must be reliable. Network security is an integral part of computer networking, regardless of whether the network is limited to a home environment with a single connection to the internet, or as large as a corporation with thousands of users. The network infrastructure can vary greatly in terms of size, number of users, and number of types of services that are supported on it. The network infrastructure must grow and adjust to support the way the network is used. The routing and switching platform is the foundation of any network infrastructure. So we have here there the chapter 1. Let's go straight to chapter 2, which is configuring a network system. Yeah, a network operating system. So here it involves the OS or the operating systems. So all networking equipment dependent on operating systems. The operating system on home routers is usually called firmware. Cisco IOS collection of network operating system uses Cisco devices. So every device that we are using, whether it is a end devices and network devices, we have the operating systems present. So we have here the access methods for accessing a Cisco device. We have telnet, the secure shell, and the auxiliary port. And navigating the iOS, we have here the primary modes, which is the user exec mode and the privilege exec mode. So global configuration mode and sub mode. So after the global configuration mode, we have the sub modes, which is the other configuration, which is the interface configurations. So securing device access, we have here the device access passwords. So we have enable password, enable secret, console password, and VTY password. Cisco iOS, the technician can enter commands to configure or program the device to perform various networking functions. Services are generally accessed by using a command line interface, which is accessed by either the console port, the AUX port, or through a telnet or SSH. Once connected to the CLI, network technicians can make configuration changes to Cisco iOS devices. Cisco iOS is designed as a model operating system, which means a network technician must navigate through various hierarchical modes of the iOS. Cisco iOS routers and switches support a similar model operating system, support similar command structures, and support many of the same commands. In addition, both devices have identical initial configuration steps when implementing them in a network. So here in the chapter 2 summary is also shown the parts of the parts of or some commands used for the user exec mode, privilege exec mode, and the global configuration mode, and of course the interface commands and the routing engine commands and the line commands. So let's go straight to chapter 3, which is Network protocols and communications. Establishing the rules, identify sender and receiver, agreed upon method of communicating, common language and grammar, speak and timing of delivery, confirmation of acknowledgement requirements. So in our communications, in our daily lives, we need to be we have to keep in mind some of the rules needed, which is the one given here. Message formatting and encapsulation. So we have here a letter, and here we have the name of the sender, the sender's address and the recipient's address, and inside are the other formats that is needed to for communicating with source to destination. Message time, we have access method, flow control, response timeout. We have here network protocols, the process by which networking devices share information about pathways with other networks. So here's the OSI reference models. We have physical data link, network, transport, session, presentation, and application. TCP IP reference model, we have the application, transport, internet, network access. Communicating the messages, segmenting message benefits, and segmenting message disadvantage. So for the summary, data networks are system of end devices, intermediary devices, and the media connecting the devices. For communication to occur, these devices must know how to communicate. These devices must comply with communication rules and protocols. TCP or IP is an example of a protocol suite. Most protocols are created by a standards organization such as IETF or IEEE. The most widely used networking models are the OSI and TCP or IP models. Data that passes down the track of the OSI model is segmented into pieces and encapsulated with addresses and other labels. The process is reversed as the pieces are encapsulated and passed up the destination protocol stack. The OSI model describes the process of encoding, formatting, segmenting, and encapsulating data for transmission over the network. The TCP or IP protocol suite is an open standard protocol that has been endorsed by the networking industry and ratified or approved by a standards organization. The Internet Protocol Suite is a suite of protocols required for transmitting and receiving information using the Internet. Protocol data units or PDUs are named according to the protocols of the TCP or IP suite, data segment, packet, frame, and bits. Applying models allows individuals, companies, and trade associations to analyze current network and plan the networks of the future. So for chapter 4, the network access. So network access chapter 4, we have here the properties of UTP cabling. So UTP cabling, cable designers have discovered that they can limit the negative effect of crosstalk by cancellation varying the number of twists per wire pair. So crosstalk means the interference made by some 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 other wires that is interfering with the UTP cable. Properties of fiber optic cabling. So this fiber optic cabling is used in 4 types of industry: enterprise networks, fiber to home and access networks, long haul networks, submarine networks. We have 2 types of fiber media: the single mode and the multi-mode. Media access control, data link layer. And data link layer protocols govern how to format a frame for use on different media. Different protocols may be in use for different media. So these are common physical one topologies: the point-to-point topology, hub and spoke topology, and full mesh topology. So half and full duplex. Half duplex, it sends the server and the switch will send will be able to send one at a time, and of course they will receive it one at a time also. It cannot send or receive at the same time, like the full duplex. So physical LAN topologies, we have star topology, extended star topology, bus topology, and ring topology. The trailer, and the start frame address type length data in the trailer having the FCS in the stop frame. FCS means the frame check sequence and the stop frame. So these two are at the trailer part in the data link frame. The TCP or IP network access layer is equivalent to the OSI data link layer, the physical layer. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. Network layer standards address three functional areas: physical components, frame encoding technique, and signaling method. Using the proper media is an important part of network communications. Without the proper physical connection, either wired or wireless communications between any two devices will not occur. Wired communication consists of copper media and fiber cable. These are main types of copper media used in networking, and shielded twisted pair or UTP, shielded twisted pair or STP, and coaxial cable. UTP cabling is the most common copper networking media. Optical fiber cables become very popular for interconnecting infrastructure network devices. It permits the transmission of data over long distances at higher bandwidths than any other networking media. Wireless media carry electromagnetic signals that represent the binary digits of data communications using radio or microwave frequencies. The data link layer is responsible for the exchange of frames between nodes over a physical network media. It allows the upper layers to access the media and controls how data is placed and received on the media. Among the different implementations of the data link layer protocols, there are different methods of controlling access to the media. These media access control techniques define if and how the nodes share the media. The actual media access control method used depends on the topology and media sharing. LAN and WAN topologies can be physical or logical. WANs are commonly interconnected using the point-to-point hub and spoke and mesh physical topologies. In shared media LANs, the devices are interconnected using the star bus ring or extended star hybrid physical topology. All data link layer protocols encapsulate the layer 3 PDU within the data field of the frame. However, the structure of the frame and the fields contained in the header and trailer vary according to the protocol. And that's it for the chapter 4 on our summary from 1 to 11. So I have here chapter 5, which is the Ethernet. So LLC and MAC sublayers. We have the Ethernet, one of the most widely used LAN technologies, operates in the data link layer, the physical layer. Ethernet standards define layer 2 protocols and layer 1 technologies. Two separate sublayers set the data link layer to operate: logical link control (LLC) and the MAC sublayers. So the LLC handles communication between upper and lower layers, takes the network protocol data and adds control information to help deliver the packet to the destination. So the MAC constitutes the lower sublayer of the data link layer, implemented by hardware, typically in the computer NIC. So the MAC's two primary responsibilities are data encapsulation and media access control. Data encapsulation. The earlier versions of the Internet were slow at 10 MB per second. So now operates at 10 gigabytes per second and faster. Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. Ethernet 2 is the Ethernet frame format using TCP or IP networks. Where the unicast MAC address, it sends the frame to one server, the server only. It sends the frame in a single destination. For the broadcast, it sends the frame to all hosts. For the multicast, it sends to a group of hosts only. MAC address, this address does not change, similar to the name of a person. Not a physical address because physically assigned to the host NIC. IP address, similar to the address of a person, based on where the host is actually located, known as a logical address because assigned logically, assigned to each host by a network administrator. Our purpose, sending notice to needs a way to find the MAC address of the destination for a given Ethernet link. It provides two basic functions, solving IPv4 addresses to MAC addresses, and maintaining a table of mappings. We have the duplex settings. We have half duplex and full duplex. Types of layer 3 interfaces. We have virtual interface, routed port in the layer 3 Ether channel. Summary. Ethernet is the most widely used LAN technology used today. Ethernet standards define both the layer 2 protocols and the layer 1 technologies. The Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. As an implementation of the IEEE 802.2/3 standards, the Ethernet frame provides MAC addressing and error checking. Replacing hubs and switches in the local network has reduced the probability of frame collisions in half-duplex links. Layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communications. Ethernet uses the address resolution protocol to determine the MAC addresses of destinations and map them against known network layer addresses. Each node of an IP network has both a MAC address and an IP address. The R protocol resolves IPv4 addresses to MAC addresses and maintains a table of mappings. A layer 2 switch builds a MAC address table that it uses to make forwarding decisions. Layer 3 switches are also capable of performing layer 3 routing functions, reducing the need for dedicated routers on a LAN. Layer 3 switches have specialized switching hardware so they can typically route data as quick as they can switch. So, we're at chapter 6. So, chapter 6, we have the network layer. The network layer. The network layer is a layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes: addressing end devices, encapsulation, routing, decapsulating. Characteristics of the IP protocol, we have firstly connectionless, the best effort delivery, and the major independent. Introducing IPv6, increased address space, improved packet handling, eliminates the need for NAT, integrated security, 4 billion IPv4 addresses, 340 additional IPv6 addresses. Default gateway. Hosts must maintain their own local routing table to ensure that network layer packets are directed to the correct destination network. The local table of the host typically contains direct connection, local network route, local default route. Router memory, we have the RAM, ROM, and VRAM in flash. The RAM is volatile, the ROM is non-volatile, and also the energy around the flash are not volatile. Inside the router, we have the power supply, shield for WIC, fan, SDRAM, and VRAM, CPU, and advanced integration module. Cisco IOS. Cisco IOS operational details vary on different networking devices depending on the device's purpose and feature set. However, Cisco IOS for routers provides the following: addressing, interfaces, routing, security, QoS, resources management. Summary. The network layer, or OSI layer 3, provides services to allow end devices to exchange data across the network. The network layer uses four basic processes: IP addressing for end devices, encapsulation, routing, and encapsulation. The Internet is largely based on IPv4, which is still the most widely used networking layer protocol. An IPv4 packet contains the IP header and the payload. The IPv6 simplified header offers several advantages over IPv4, including better routing efficiency, simplified extension headers, and capability for per-flow processing. In addition to hierarchical addressing, the network layer is also responsible for routing. Hosts require a local routing table to ensure that packets are directed to the correct destination network. The local default route is the route to the default gateway. The default gateway is the IP address of a router interface connected to the local network. When a router such as default gateway receives a packet, it examines the destination IP address to determine the destination network. The routing table of a router stores information about directly connected routes and remote routes to IP networks. If the router has an entry in its routing table for a destination network, the router forwards the packet. If no routing entry exists, the router may forward the packet to its own default route. If one is configured, it will drop the packet. Routing table entries can be configured manually on each router to provide static routing, or the routers may communicate route information dynamically between each other using routing protocol. For routers to be reachable, the router interface must be configured. So for chapter 6, we have 5 left. So we have the chapter 7, which is the IP addressing, binary and decimal conversions. A binary is a numbering system that consists of numbers 1, 0, and 1 called bits. Clustered decimal number system consists of 10 digits consisting of the number 0 to 9. Binary is important for us to understand because host servers and network devices use binary addressing. IP address addressing structure. IP address gives a device a unique address over a network. Subnet mask used to identify the network of and the host portion of an IPv4 address. The ones identify the network portion and the zeros the host portion. Now we have types of IPv4 address. We have public IPv4 addresses. Our private addresses starts with 10, 172, and 192. Special user IPv4 address. We have the loopback addresses, linked local addresses, and testnet addresses. IPv4 issues, the need for IPv6, depletion of IPv4 address space, Internet of Everything. The evolving Internet is becoming an Internet of Things. No longer will the only devices accessing the Internet be computers, tablets, and smartphones. The sensor-equipped Internet-ready devices of tomorrow will include everything from automobiles and biomedical devices to household appliances and natural ecosystems. Unlike IPv4, which 32 bits, IPv6 is 128 bits. IPv4 is approximately 5.2 billion IP addresses, but IPv6 is 340 antecedent addresses. Prefix length of IPv6 indicates the network portion. Format IPv6/prefix length. Prefix length range from 0 to 128. Typical length is /64. Common types of IPv6 addresses. We have the global unicast addresses, linked local unicast addresses, unique local addresses. Common types of IPv6 addresses. We have the linked local unicast addresses. Dynamic configuration or SLAC, stateless address auto configuration, is a method that allows the device to obtain its prefix, prefix length, default gateway address, and other information from an IPv6 router without the use of a DHCPv6 server. Using SLAC, devices rely on the local router's ICMPv6 router advertisement messages to obtain the necessary information. IPv6 routers periodically send out ICMPv6 RA messages every 200 seconds to all IPv6 enabled devices on a network. An RA message will also be sent in response to a host sending an ICMPv6 router solicitation message. ICMPv6 network prefix and prefix length and default gateway address and DNS addresses and domain name. The ICMPv6 RA message is a suggestion to a device on how to obtain an IPv6 global unicast address. The ultimate decision is up to the device's operating system. The ICMPv6 RA message includes network prefix and prefix length, plus the device which network it belongs to. Default gateway address. This is an IPv6 linked local address, the source IPv6 address of the RA message. DNS addresses and domain name, addresses of DNS servers and a domain name. Multicast IPv6 multicast address. Assign IPv6 multicast addresses. IPv6 multicast addresses have a prefix of FF00/8. Solicited node IPv6 multicast addresses. ICMP, ICMPv4, and ICMPv6. As confirmation, destination or service unreachable, time exceeded, router redirection. Testing and verification, we have the ping and the trace route. Ping is testing the local stack while trace route is testing the path. Summary, explain the use of IPv4 addresses to provide connectivity in small to medium-sized business network. Configure IPv6 addresses to provide connectivity in small to medium-sized business networks. Use common testing utilities to verify network connectivity. And next is the Chapter 8. Chapter 8, which is the subnetting IP networks. So Chapter 8, subnetting IP networks. So we have here the term subnetting. It's the process of segmenting a network into multiple smaller network spaces called subnetworks or subnets. So subnetting is making a single IP address to have many subnetworks. Communication between subnets. A router is necessary for devices on different networks and subnets to communicate. Basic subnetting, borrowing bits to create subnets, borrowing 1 bit, 2 raised to 1 is equal to 2 subnets. Subnets in use, we have here the image for the subnets in use. So subnetting formulas, we have calculate number of subsets. We have 2 raised to n, where n is the number of bits borrowed. Also, calculating number of hosts is the same thing. Creating 4 subnets, we have borrowing 2 bits to create 4 subnets. 2 raised to 2 is equal to 4 subnets. Creating 8 subnets, we have create 8 subnets is 2 raised to 3 is equal to 8 subnets. Subnetting based on host requirements, we have to consider 2 planning subnets. 2 configurations when planning subnets. Number of subnets required, number of host addresses required. Formula to determine number of usable hosts, 2 raised to n minus 2. So 2 raised to n is used to calculate the number of hosts, while minus 2 is because the subnetwork ID and broadcast address cannot be used in each subnet. 2 raised to n subnet needed for each department. Subnetting to meet network requirements. Balance the required number of subnets and hosts for the largest subnet. Design the addressing scheme to accommodate the maximum number of hosts for each subnet. Allow for growth in each subnet. Traditional subnetting waste addresses. Traditional subnetting use the same number of addresses is allocated for each subnet. Subnets that require fewer addresses have unused addresses. For example, one links only need 2 addresses. Variable length subnet master or VLSM. A variable length subnet master or VLSM or subnetting a subnet provides more efficient use of addresses. VLSM allows the network space to be divided in unequal parts. Subnet mask varies depending on how many bits have been borrowed for a particular subnet. Network is first subnetted and then the subnets are resubnetted. Shown here is the basic VLSM scheme. So it just using subnetting it creates more addresses in one of the addresses given here. So 3 more bits borrowed from subnet 7. VLSM in practice. Using VLSM subnets, the LAN and WAN segments in the example below can be addressed with minimum waste. Each LANs will be assigned subnet with /27 mask. Each one link will be assigned with a subnet with /30 mask. Planning to address the network. Allocation of network addresses should be planned, documented for the purpose of preventing duplication of addresses, providing and controlling access, monitoring security and performance. Subnetting using subnet ID. An IPv6 network space is subnetted to support hierarchical logical design of the network. So this is chapter 8 summary. Let's change that. Chapter 8 summary. Subnetting is the process of segmenting a network by dividing it into multiple smaller network spaces. Subnetting a subnet using VLSM was designed to avoid wasting addresses. IPv6 address space is subnetted to support the hierarchical logical design of the network. Size, location, use, and access requirements are all considerations in the address planning process. IP networks must be tested to verify connectivity and operational performance. That's it for chapter 8. Next is for chapter 9. Chapter 9. Chapter 9, which is the transport layer. Role of the transport layer. The transport layer is responsible for establishing a temporary communication session between two applications delivering data between them. So in TCP or IP, we have two protocols, which is the TCP or the Transmission Control Protocol, or the UDP, which is the User Datagram Protocol. Segmenting the data enables many different communications from many different users to be interleaved or multiplexed on the same network at the same time. So TCP, connection-oriented, creates a session between the source and destination. This has the reliable delivery, the transmitter lost or corrupt data, order data reconstruction, flow control, and stateful protocol. So for UDP, we have connectionless, unreliable delivery, no ordered data reconstruction, no flow control, and stateless protocol. Transport layer divides data into pieces and adds a header for delivery over the network. Three-way handshake establishes that the destination device is present on the network, verifies that the destination device is an active service and is accepting requests on the destination port number that the initiating client intends to use for the session, informs the destination device that the source client intends to establish a communication session on that port number. Step 1. In the three-way handshake in the TCP, the initiating client requests the client-to-server communication session with the server. Step 2. The server acknowledges the client-to-server communication session and requests a server-to-client communication session. The initiating client acknowledges the server-to-client communication session. Acknowledgement and window size. The sequence number and acknowledgement number are used together to confirm receipt. The window size is the amount of data that the source can transmit before an acknowledgement must be received. UDP, simple protocol that provides a basic transport layer function used by applications that can tolerate small loss of data, used by applications that cannot tolerate delay, used by DNS, Simple Network Management Protocol, SNMP, Dynamic Host Configuration Protocol, DHCP, Trivial File Transfer Protocol, TFTP, and IP telephony or VoIP, and modern games. UDP server and client processes. UDP-based server applications are assigned well-known or registered port numbers. UDP client process randomly selects port number from range of dynamic port numbers as the source port. Applications that use TCP, we have the IP, HTTP, FTP, SMTP, and Telnet. For the applications that use UDP, we have IP, DHCP, DNS, SNMP, TFTP, VoIP, and IPTV. Summary. Oh, this is chapter 9. My God, it gets switched. The role of the transport layer is to provide three main services: multiplex, segmentation, and assembly, and error checking. Dividing data received from an application into segments, adding a header to identify and manage each segment, using the header information to assemble the segments back into application data, passing the assembled data to the correct application. How TCP and UDP operate in which popular applications use each protocol. Transport layer functions are necessary to address issues in QoS and security in networks. Ports provide the tunnel for data to get from the transport layer to the appropriate application at its destination. So let's move on to chapter 10. We have two left. So here we have the chapter 10 on the application layer. So presentation session layer. The presentation layer is coding and conversion of application layer data, data compression, data encryption for transmission, decryption of data upon received by the destination. Session layer functions, creates and maintains dialogues between source and destination applications, handles the exchange of information to initiate dialogues, keep them active, and to restart sessions. TCP or IP application layer protocols, we have the domain name service protocol, or the DNS, used to resolve internet names to IP addresses. Telnet, a terminal emulation protocol used to provide remote access to servers and networking devices. Bootstrap protocol, a precursor to the DHCP protocol, a network protocol used to obtain IP address information during boot up. Dynamic Host Control Protocol, DHCP, used to assign an IP address of the mass default gateway in the server to a host. Hypertext Transfer Protocol, or HTTP, used to transfer files that make up the web pages to the world of the World Wide Web. Now, File Transfer Protocol, FTP, used for interactive file transfer between systems. Trivial File Transfer Protocol, TFTP, used for connectionless active file transfer. Simple Mail Transfer Protocol, SMTP, used for the transfer of mail messages and attachments. Post Office Protocol, POP, used by email clients to retrieve email from a remote server. Internet Message Access Protocol, IMAP, another protocol for email retrieval. Peer-to-peer networks, both devices are considered equal in the communication. The roles of client and server are set on a per request basis. This is the client-server model. The application layer protocols involved in every work or play include HTTP, SMTP, and DPoP. HTTP and HTTPS, developed to publish and retrieve HTML messages used for data transfer, specifies a request response protocol, 3 common messages types as GET, POST, and PUT. GET is a client request for data. POST and PUT are used to send messages that upload data to the server. So you have here the common application layer protocols, which is the SMTP, Post Office Protocol, and the IMAP. So these are the protocols responsible for the transmission of the mail to the server. Also to send emails or retrieving emails. DNS message format. DNS server stores different types of resource records used to resolve names. It contains the name, address, and type of record. DNS lookup Operating system utility called nslookup allows the user to manually query the name servers to resolve a given host name. Utility can be used to troubleshoot name resolution issues and to verify the current status of the name servers. Dynamic host configuration protocol. DHCP allows a host to obtain an IP address dynamically. File transfer protocol. FTP allows data transfer between a client and the server. Getting the data to the right application. The end device, the service port number directs the data to the connect conversation. Summary. Applications are computer programs at which the user interacts and which initiate the data transfer process at the user's request. Services are background programs that provide the connection between the application layer and the lower layers of the networking model. Protocols provide the structure of agreed upon rules and processes that ensure services running on one particular device can send and receive data from a range of different network devices. HTTP supports delivery of web pages to end devices. SMTP, POP, and IMAP support sending and receiving email. SMB and FTP enable users to share files. P2P applications make it easier for consumers to seamlessly share media. DNS resolves the human legible names used to refer to network resources to numeric addresses usable by the network. All of these elements work together at the application layer. The application layer enables users to work and play over the internet. For the last, this is for the last. The last chapter for my chapter 1 to 11 summary. So you have the chapter 11, the last. So build a small network. Devices in a small network. We have small network topologies. Comprises one router, a couple switches, and the user PCs. Now, device selection for a small network. Security, QoS, VoIP, L3 switching, NAT, and DHCP. IP addressing for a small network. Address space is a crucial component of a network design. All devices connected to the network require an address. The address scheme must be planned, documented, and maintained. Address space documentation can be very useful for troubleshooting and control. Address documentation is also very important in controlling resource access. Small network application protocols. Common applications. Network applications. Application layer services. Common protocols. Processes on either end of the communication session. How messages are sent and expected response. Types and syntax of messages. Meaning of informational fields. Interaction with the next lower layer. Voice and video applications, infrastructure, VoIP, IP, telephony, real-time applications. Security threats and vulnerabilities. We have types of threats. Digital intrusion can be costly. Intruders can gain access through software vulnerabilities, hardware attacks, and stolen credentials. Common types of digital threats include those listed in this graphic. The physical security, hardware, environmental, electrical, and maintenance. Types of vulnerabilities. Three primary vulnerabilities: technological configuration and security policy. Endpoints can be under attack, such as servers and desktop computers. Any of these three vulnerabilities can be exploited and used in attacks. Network attacks. We have types of malware, viruses, worms, Trojan horses. Reconnaissance attacks. Discovery and mapping of systems and services. Acquire enough information on the target system or network to facilitate the search for vulnerabilities. Common tools rely most on free and public internet services such as DNS and voice. Port scanners and packet sniffers are also commonly used in reconnaissance. Network attacks. We have access attacks, password attacks, trust exploitation, port redirection, and man in the middle. Denial of service attacks. Although simple, these attacks are still dangerous. Prevent or trace people from using a service by consuming new sources. Prevent those attacks by applying the latest security updates. Common DOS attacks. Picking of death, SYN flag, DDoS, and Smurf attack. Network attack mitigation. Backup, upgrade, update, and patch, keeping up to date with the latest developments. Enterprises need to keep current with the latest version of antivirus software. Patches for all known vulnerabilities must be applied. Authentication, authorization, and accounting. AAA services provide access control on a network device. Authentication, access a resource. Authorization, what they can do. Accounting, actions performed while accessing the resource. The AAA framework can be very helpful when mitigating network attacks. Firewalls, a firewall controls the traffic, helps prevent unauthorized access. Techniques for determining what is permitted on denied access to a network include packet filtering, application filtering, URL filtering, and stateful packet inspection. Endpoint security. Common endpoints are laptops, desktop servers, smartphones, and tablets. Securing endpoint devices is challenging. Employees need to be trained in proper use of the network. Policies often use for antivirus software and host intrusion prevention. More comprehensive endpoint security solutions rely on network access control. Device security. Default settings are dangerous because they are well known. Cisco routers have a Cisco Auto Secure feature. Passwords. Use strong passwords. Strong password has/is. Has or is at least a characters, preferably 10 or more. A mix of uppercase and lowercase letters, numbers, symbols, and spaces. No repetition, no common dictionary words, no letter or number sequences, no usernames, relative or pet names, and no other easily identifiable pieces of information. Misspelled words, changed often. Basic security practices, we have the service password encryption command. It encrypts passwords in the communication. In the configuration, security passwords mean length. It ensures all configured passwords have a minimum specified length. Login block for 120 attempts 3 within 60. It will block login attempts for 120 seconds if there are 3 failed login attempts within 60 seconds. Enable SSH. Telnet is not secure. It's highly recommended to use the SSH for remote shell protocol. Show commands. The Cisco IOS CLI show commands are powerful troubleshoot tools. The show command display configuration files, checking the status of device interfaces and processes, and verifying the device operational status. So we have the show commands. Show running config, show interfaces, show ARP, show IP route, show protocols, and show version. Troubleshooting methodologies. Basic troubleshooting approaches. Identify the problem, establish a theory of probable causes, test the theory to determine cause, establish a plan of action to resolve the problem, and implement the solution. Verify full system functionality and implement preventive measures. Document findings, actions, and outcomes. Summary, explain how a small network can scale into a larger network. Configure switches and routers with device hardening features to enhance security. Use command show commands and utilities to establish a relative performance baseline for the network. Apply troubleshooting methodologies in command host and IOS commands to resolve problems. Explain how a small network of directly connected segments is created, configured, and verified. And there we have the last chapter on our quick summary about the chapter 1 to 11, and I have already uploaded my individual videos about each chapters. I just quickly summarize each in a very easy way, and I hope you enjoy my video, and thank you for watching, and stay tuned for my videos, and goodbye.